Well, we're back at another exciting adventure of CNBT 1311. Escalators and moving sidewalks. Escalators are power-driven stairways consisting of steps attached to a continuously circulating belt. These belts are heavy, they're steel, all right, with interlocking stairs. If you've ever seen the inside of one of these things as they're working on them, they're quite intriguing. Escalators have been around for a long time. Just like elevators, they can move large numbers of people efficiently and comfortably between a limited number of floors. 6 floors is generally the max. They move at a constant speed, so there's particularly no waiting period, but there should be adequate queuing space at each loading and discharge point. Escalators may not be used as required fire exits. All right. The problem with escalators, if they go down, you can't use them at all. You cannot use them as a set of stairs because you're riding the tread up. All right. And if you've ever seen an escalator that's not working, that's down, it has a decreasing riser, an increasing tread deal. And the safety personnel, if it's an escalator that's down, need to have this thing barricaded off so people can't try to walk up it. It's a safety hazard. And they're okay for people with some degree of ambulatory issues. But again, there needs to be a secondary set of stairs, fixed stairs with a fixed ratio to accompany these. If they don't work, they cannot be used as fire exits. All right, moving sidewalks is just that. It's a conveyor belt you stand on. He talks about it being along low inclines. Doesn't have to be an incline. It could be just a flat place like in an airport, where you just stand on a conveyor belt and instead of walking, it moves you along. I've seen a lot of people get on the moving sidewalk at the airport and then walk along with the moving sidewalk. But nonetheless, if this thing goes down, you can still walk on it if you need to. All right, fireplaces. Now we're going to throw fireplaces in. All right, fireplaces. This is an open front. This is an open front and side. So here's open front means it's just got an open front. This is an open front and an open side. And then you have a two-sided, open front and back. That goes all the way through. Open front and back. They all have similar things. Okay, here's a damper. Here's some general dimensions. It's an open front. Let's see here. The flue creates a draft that carries it up through the chimney. Smoke chamber connects the throat of a fireplace to the flue of the chimney. This is your smoke chamber. Smoke shelf at the bottom of a smoke chamber deflects down drafts from the chimney. The throat's the narrow opening between the firebox and the smoke chamber. It's fitted with a damper that regulates the draft in the fireplace. This is be your damper, okay? And you can adjust it to make it wide open or narrow, okay? If these things are not constructed properly, you have set up a potential fire hazard in your house or your structure. This is the hearth, which needs to be fire retardant, fireproof material like ceramic or something. Needs to be non-combustible. Best thing is brick or stone. The dimensions and proportions. Fireplace radiates heat depending on what's out here. If this is an open firebox, like a metal firebox, and then you've got brick veneer around it, and the back's open to the outside, then you're not going to get much radiating heat. You'll get some through here, but most of it's going to go out the sides and then out the back, depending on how it's constructed. It needs to draw properly, of course, to carry the smoke and other things out the chimney. Sustain combustible fuel of wood. Radiate the maximum amount of heat into the room and ensure proper distances from combustible materials. They have interior heat exchangers that hook to a fan and actually blow the hot air into the room. There's all kinds of combinations of different ways to handle heating a house with a fireplace. Mine's just a firebox, a metal firebox that is on an outside blivet. Here's the brick masonry wall. Here's a covering. Inside here's a firebox. Goes to a brick hearth. And as you can see, all this is airspace on the outside of the house. None of this is insulated. So if you build a fire in this fireplace, most of your heat is going to the outside. Not very efficient. Not very efficient at all. My wife wants gas logs put in, and if we do that, we're going to have to find a heat exchanger that actually works to blow the hot air back into the living room. But for years it hadn't been used. So I'll have to get a chimney sweep before we do that to come out and do it. Here's some typical fireplace dimensions in inches. Open front and side, and open front and back. Your mileage is going to vary. This is a detail of a old style, oh my God, old style, actually built in place fireplace. I don't know of any masons that actually know how to do this anymore. Here's the damper. Here's your fire brick. Firebox is made out of fire brick. This is fire brick. This is masonry. You got to get this angle right. All these legend bubbles are tied to a legend. Well, where's this bloody legend? Well, anyway. Oh, here it is up here. Here's the dimension legends up here. Typical fireplace dimensions in inches. All right. All right. All these bubbles on this diagram go back to. Let me check a later edition. Yeah, it's the same thing. They go back to the chart on page 918. Anyhow, you got to get this angle right, or it's not going to draw. This is a good one. It's got an air intake, and you do need air intake, combustible air, or you're going to be sucking air out of your house to feed the fire. Here's the damper. Here's a deflector shield going up here, draft shield, whatever you want to call it. This is all lined, and well, this is a fancy one. This got fire clay flue lining. Yeah, this is an expensive freaking fireplace. Oh my God. Most of them in these houses today are pre-manufactured fireboxes with all of this built in, and then you have a sheet metal flue that goes up that's insulated, and then it goes up through the chimney. All right. Speaking of chimneys, let me open up another document. I should have done that before I lit this thing off. Fireplaces and stoves. All right. The Ben Franklin stove, we'll talk about that in a minute. Let's open that with Microsoft Edge. Let's open chimney fires. Let's open that with Microsoft Edge. And let's open this with Microsoft Edge. No, I ain't get tool. All right. This document is up on D2L in this week tab where this chapter goes. It talks about how to pick one, gives you some ideas on how to pick a wood stove. My uncle had a wood stove in his house that was all enclosed, and it had a fan that with a heat exchanger on the outside, and it would blow the hot air. And it wasn't a romantic fireplace. You'd put a log inside, close the door, and that log would burn for a long time. And it was to generate heat, not to generate romance of an open fire. You know, where you could roast your chestnuts and lay on a bearskin rug and drink wine and read philosophy with your lover. All right, chimney. We talked about flashing before. Remember our little talk about flashing? All right, this is talking about chimney fire safety. The problem with chimneys is they get creosoted up. That's the oily byproduct from wood. Down here in the south, if you're using a lot of pine to burn in your fireplace, you're going to have a lot of creosote. That's the oil out of the pine that's heated up and deposited on the inside of your chimney. And if you don't get it swept out and cleaned periodically, don't be surprised if your chimney doesn't catch on fire. Because that creosote, once it gets super hot and enough of it, it will burn. So it needs to be done with a certified chimney sweep. How you like this flashing around this? Isn't this cool? Boy, look at that flashing. Isn't that neat? Yeah, I'm sure that's really watertight. How the chimney sweeps get in here is they got to take this cap off, and they go down with their brushes, and they got vacuums underneath, and they do their thing. But you need to get your chimney inspected and certified, and I would suggest that you limit the amount of pine that you burn in your fireplace. Now this is New York State, but it's all the same thing. Because inside the flue gets deposits from whatever you're burning. Okay, and if you're burning a lot of pine, you have the propensity of coating this section up through here with creosote. Now let's go back. How to choose a wood stove. We already talked about that. All right, so you can read that if you want to choose a wood stove. The chimney fires, we talked about that. And the lovely flash job on that. All right, so we're going to close this. And no, I don't want to save it. Leave it anyway. So what about the Benjamin Franklin stove? We'll get to that in a minute. All right. So this is a typical built-in fireplace. You do have to have combustion air. If not, you're going to have to open a window in the house, or you'll suck the oxygen right out of the house if you get a rolling fire in there. Masonry chimneys, we're still talking about that. This is old style. We got the chimney tile up on the roof. Most efficient type come prefabricated fireboxes with the flue up to the chimney, and then these are you have a built-in outside box that's framed up, and then there's enough space in between there and the chimney pipe that you don't have to worry about it. Okay. Every one of these requires their own flue. Let's see. This is a chimney hood. So that's 2 flues, so they must have 2 down there in the house. Prefabricated fireplaces and stoves are probably your biggest bang for the buck. That's why you see them in all these tract houses, and even the custom homes have this. These things are designed and engineered to work. Some of them come with air returns, come with fresh air for combustible intake from the outside, and these will have a damper in them. Some of these will have a gas line running through them, a natural gas line to help start the fire, or you can put gas logs in there and not worry about burning wood and then taking ash out. Some have a heat exchanger where basically what's being burnt inside is a tube, just like a regular heat exchanger in a refinery. This would be your fire. It's heating up the tubes. This goes over to a fan that has a bank, so that comes over. Here's a fan. Could be integral to it or off to the side. So it forced air through the heat exchanger and then out into the room. So not all your heat's going up the chimney. Because if this is built on the exterior wall of the house, which it will be, a lot of your heat's going to escape going back out, like I said before, to the to the outside. Here's all the nomenclature and definitions of these things. Here's your rain cap. This is your hood up here and your collar. Let's see. Now this is a stove. This is a wood-burning stove, or Benjamin Franklin stove. These are your prefabricated fire boxes that you have to then build around. That's what I've got in my house. Benjamin Franklin stove. We put one of those in our house up at the lake when I was, 8 years old. We've still got that place. My mother retired and is living up there. And that stove's been there for years, and it will get hot enough to drive you out of that room. We'll talk more about the Benjamin Franklin stove. It sits on a very large brick hearth, and then there is a brick veneer wall behind it. That's how we designed it. And it's been there for a gazillion years. Well, not a gazillion, I'm 69. It's been there for 61 years. Still working fine. It's a brick veneer, and behind it is gypsum sheetrock for the fireproofing. And the metal chimney goes up through here, through the roof. It has this offset. This is a fire stop spacer. It's called a fire stop spacer. It's just a big ring that sets in between the framing. There's one up here too. This is your flashing cone. And if I'm not mistaken, I think we put a fire stop spacer up here too. But this house now has a metal roof on it, and it gets super hot. So all the heat in this cast iron or steel, welded steel firebox, ours is cast iron, stays in the house. Back heat radiance off this masonry wall heats it up as a thermal mass, radiates out the side, and the modern ones have built-in heat exchangers that have a fan, even blows a hotter air out further out into the room. And verify installation details and requirements with the stove manufacturer and build code. Here again, follow the directions of the building code. So all right, let's go look at the Benjamin Franklin stove. And why is it called a Benjamin Franklin stove? Because Benjamin Franklin invented it. Benjamin Franklin and fireplace. This is an article. I'm not going to read this to you. You read this on your own. He set out to invent a fireplace that would be safer and more efficient, and he succeeded in 1742 at the age of 36. Okay? So, this is pretty much what ours looks like. It's a traditional Benjamin Franklin stove, and many people still use these. And there are variations on the Benjamin Franklin stove. I told you about that stove that my uncle had. It is a smaller box and didn't have an open deal, so you didn't have the romantic fire. It was enclosed, and it was as efficient as any wood burning thing could get. They have pellet burning wood stoves, much like the Traeger barbecue grills. Like I said, some of these have heat exchangers built into them with fans. These are the most efficient, biggest bang for the buck of heating the inside of a structure with wood, and not having all the drawbacks of a traditional fireplace, or even a prefabricated firebox, because most of them are not designed. The fireboxes are designed by the manufacturer well, but they're not installed with the idea of radiant barriers and keeping the heat back into the residence. Benjamin Franklin stove does that for you. Okay, so this is why it's called a Benjamin Franklin stove, and I'm sure most of y'all will not read this, but you might. Now, there's a man named Rittenhouse that added an L-shaped chimney, and he called his improved appliance a Rittenhouse stove in the late 1780s. But it's still a Benjamin Franklin stove. And again, there are wood stove manufacturers that have improved on this with modern technology, and this you're getting the most bang for your buck. And you burn oak in this like you would on a stick burning barbecue pit, not pine. If you burn pine up in here, you're still going to have the propensity of getting your chimney contaminated with creosote, the heated residue of the pine oil. All right, that's on D2L also, if you care. All right, let's go back over here. So anyway, this is the Benjamin Franklin stove. Kitchen layouts. Oh my goodness, kitchen layouts. Man, are we covering a lot of real estate. You could spend a whole semester on kitchen layouts and bathroom design. There are people that specialize in that, kitchens and bathrooms. All right. How much money you got to spend? The typical bathroom remodel in a typical residence starts at about $25,000. Typical kitchen remodel is around 30 to 35 to gut one and start putting it back together, and that's with cheap stuff. We are not going to go through all this stuff. The refrigerator, the sink, and the range. What's the control flow in the kitchen? How are you going to prepare? If you're a foodie and you cook like my wife is, our kitchen, when we first bought the house had an L in it. I cut the L out, and we've done a lot of remodeling in the kitchen. I did the work myself. And it's not the best. It's not, but it now serves our needs, and she likes it. It's not what we would design if we had unlimited funds, but it works, and that's what we decided when we were cutting the L island out with the stove in it over here, and then moving the stove and oven in here. It had a stacked stove and oven over here. Not a stove, but an oven. We took that out, put cabinets in, all kinds of stuff. And but you got to worry about the pattern. What is the pattern of movement in the kitchen? I mean, you don't want to have to cover 30 acres to get from the refrigerator over to your food preparation area. Now, this is not a course in interior decorating, but again, these are things you got to think about. This is parallel walls. This is an L shape. Again, how's the pattern going to work? This is a U shape kitchen. There are companies like Viking that sell those high-end ranges and refrigerators and dishwashers. They have design centers that can help you lay all this stuff out. If I'm not mistaken, I think Lowe's and Home Depot also, and some of them have a design center. There are people that specialize in kitchen remodeling and design. You at least want 60 inches or 5 feet circle space in here, or people be bumping into each other. I don't particularly like a U design, but and maybe what you have to deal with, and then you just have to go with it. Everything's a compromise. I mean, unless you have unlimited funds. And then what about the ADA? ADA accessibility guidelines. Got an under counter space, 27 inches wide at least to get your legs underneath it. Counter height tops. All of this goes in. You got to be able to turn a wheelchair around. And then the normal cabinet height, or countertop height, has to be lower for ADA. Then they got to lean over the sink to do the dishes. There's all kinds of stuff. That's what I'm saying. The government has that thick ADA design handbook that you can get online for free. Lighting is a big requirement in a kitchen area. The amount of lighting, the amount of counter space, the amount of cabinet space. Where's your pantry going to be? You're going to need 2 refrigerators or 1. You know, we got 2, one inside and we got 1 outside underneath the cover. There are probably as many iterations on kitchen designs. That's why if you go to the store, look at the magazine section on kitchen design. It's endless. Integration of electrical, plumbing, and mechanical systems. You got to get water in, you got to get water out. Okay, if this is electric, then you're going to need a 240 volt single phase circuit. If it's gas, then you'll need 110 and you'll need a gas line in there. Then what about your electrical appliances on your counter? Your air fryer, your blender, your coffee pot. That's all 110 single phase. That's all 120 single phase. That's single phase. All right. kitchen dimensions. 24 to 36 inch sink center, range center. Here's some dimension ranges here. It's not a one size fits all. You can see it ranges from 36 to 42 for here. The 14-inch minimum clearance between the center of the front heating unit and the turn of counter. 18 to 24 inches counter space on each side of the range. What's the material made out of on the countertop? Is it marble or is it synthetic? If it's synthetic and you lay a hot pan on it, it's going to burn the synthetic. If it's stone, then it's not going to burn. We redid our countertops, ripped up the Formica and put in marble pavers because it was weird dimensions in here. Here's some more ADA requirements. Refrigerator, and they come in different sizes. What about your dishwasher? They all have a general standard size, but you better check with your appliance manufacturer to see if you got a hole that'll work. And then lay all that out. Then you get with your cabinet people, your cabinet makers, and your range hood. Is it a recirculating range hood, or do you need to vent this range hood? Vent it out the wall, or vent it up. If this is right over the second floor, you may not be able to vent it up. You may still have to vent it up into the ceiling space and then turn it and then take it out to a rain-proof cap on the outside of the wall. Or is it a recirculating? If it's recirculating, it's not going to vent smoke out. It'll just recirculate stuff. If this is an ADA accessible sink, there's got to be room underneath that thing for the legs to go, right, from the wheelchair. So you've got to think about all of this. If you're not worried, if it's a residence, then and nobody's ADA, then you don't have to worry about it. But what if you do become ADA? Then you got to come in and start cutting holes and stuff, or you're not going to be able to get to anything. All right. Now we get kitchen cabinets, which is a whole nother course. All right. There are people that do nothing but specialize in kitchen cabinets, from low-end pieces of junk you get at Lowe's and Home Depot to the high-end stuff that you can get through Lowe's and Home Depot or at custom cabinet shops. And they come in standard units and ranges. All of this is a combination wall unit. This is a basic wall unit. This is a drawer unit, a basic base unit. Then they got a sink base unit. And when it comes to sinks, is it going to be an underhung sink, or is it going to be a top mount sink? In other words, here's a detail for a top mount. Here's your countertop, and your sink has a lip, and then this is your sink, and that's a drain. Okay, blah, blah, blah. All right, and if it's an underhung, this is your countertop. And then the sink is mounted underneath. There's a drain. Structural clips and support, depending on what your sink's made out of. Okay, so water on the countertop. Hopefully it's sloped a little bit, so any water on the countertop will drain into the sink. Here, any water on the countertop beads up right there at that lip. So this is a top mount sink. This is an underhung sink. Underhung sinks, if it's the same depth sink, is going to eat up more space underneath the cabinet. You got to take that in consideration. Do I have room for the disposal and all the plumbing that has to go out? and what's the underneath of the cabinet manufactured. If it's junk cabinet and you put a cast iron sink in here, you may have to do some shoring up. If it's custom cabinets, like when I redid our cabinets, I took the 50-year-old existing sink cabinet and reinforced it with laminated glue and to support that cast iron sink. That's a top hung. That's a top mount. Okay. Let's move on. A wall oven unit. That's assuming you got one oven. If you've got a double oven, then you're going to need. This will be cut out. When I removed the vertical oven on one end of there and we went to a combination ranging oven, I turned that whole section over there into two big long lateral drawers for the pots and pans. Here's a base corner unit. My mother has one of these in her house up at on the Lake Belton at Temple, Texas. It's in a corner unit. It just rotates around like a lazy Susan, and corners for conventional cabinets tend to have a waste of space. I mean, think about it. If you have a traditional rectangular cabinet that comes in, and then you've got an equal depth cabinet coming across, then what do you do with this? If this is where maybe the dishwasher is, and now this is cabinet doors or drawers that slide out, then this space in here is boxed off and dead. You can't get to it. You can't use it. You can use a countertop, but you can't use that space in there. So maybe this is a way to solve that problem for you. So that's a base corner unit. Like I said, that's a lazy Susan that rolls around. That is not a base corner unit. What the hell is he calling that? And he's still calling it a base corner unit. In the 5th edition. I see what he's doing. Okay. All right. I see where he's headed with this. You're just going to make up another cabinet in here, but you're still going to have all this is going to be dead space in here. I see what he's doing. Okay. All right. And this is a kitchen casework that's all prefabbed. Your mileage is going to vary. All right, what about ventilation in the kitchen? You've got to have ventilation in the kitchen. You've got to have ventilation in the kitchen. There are minimum rules of thumb. Okay. All right, so let's look and see what he says. Your building codes may actually govern this. You got to check them. Provide natural ventilation by means of an operable exterior openings, like a window, an area not less than 1/20 of the floor area with a minimum of 5 square feet. Mechanical ventilating system, providing a minimum of 2 air changes per hour, may be employed in lieu of natural ventilation. All right, you need to listen to me very careful. This says 2 air changes per hour. That means the total volume of this kitchen gets changed out twice in an hour. This is low, very, very low, very low. If you look at the requirements for kitchens with a lot of cooking activity, you will see stuff published from 2 air changes an hour up to 15. Now, there's a problem with fans. It's called the SON rating. SON rating, that's the noise of a fan, just like a ventilation over your stove. the more it sucks out, the noisier that fan's going to be. All right, 2 is extremely low. It's very, very minimum. Okay, like I said, I have seen figures from 2 to 15 air changes per hour in a kitchen, especially if you're doing a lot of frying and generating a lot of smoke from the cooking. Here's a range top ventilator that's being ducted out through the wall or up through the roof if this is a single story house, or even lateral in the soffit above the cabinets and then out someplace. This stuff's got to go. This is not a recirculating one. Self-venting cooktops may exhaust directly to outside or an interior location. Sometimes there'll be a slit right here. I think, who was that company? Was it Gen Air? They used to make a range top and a broiler. In fact, we had one when we moved in this house, and it had to be ventilated. And it was ventilated out and wasted a lot of under cabinet space with the ventilation system. But I've seen some of these where they're ventilated out. They go straight down and then out through the slab, and this is the exterior wall. Let's see. Electrical needs, again, I already talked about that. How many of these? I put a bunch of electrical outlets when I redid the kitchen. We got electrical outlets on everything that we did. So we got plenty of electrical outlets. This has a minimum of 2 circuits for small appliances should be provided. Your building codes are going to govern that. Some codes will require you to put GFIs in the kitchen, just like the GFIs in your bathroom. That's ground fault interrupter. Now the problem with GFIs is the more they trip, the worse they get, and you'll need to replace them. And special single outlet circuits are required for heavy appliance like ranges. If this is an electric range, I guarantee you're going to run a separate circuit. You're going to run a separate home run from your panel box, and it'll be 240 volt. That'll be 240. Your other appliances in here are going to be 110. So you will need a separate home run for this. Electric range and electric oven for 240 volt single phase. Gas appliances require separate fuel lines. Well, no kidding. And if that's the case, then you'll run a gas line through here, and it'll still need a 110 for the clock and the electrical and the lights and stuff in the oven and anything else. Vent hoods are 110. They're going to be 110, and I mean, unless you get one that'll suck you to the moon, but they're all 110. And let's see. He's pointing to waste plumbing. This is going to go out through the exterior wall. Here's a typical window over the sink. Depending on how you heat your house, if it's a regular house down here, then your heating is going to come from the ceiling, not from the floor like it would up in Colorado or in the cold country, where you've got embedded hot water pipes in your flooring. Bathroom layouts. We're at 44 minutes. Maybe we ought to do bathrooms on the next video. Now, what kind of bathroom? Residential bathroom, commercial bathroom, ADA bathroom, industrial bathrooms like in a school for a gym. These all require different codes, different specifications. There are people who specialize in bathroom layouts. We've got, how many pages we got left? let's just go ahead and make this a long video and be done with it. This will end chapter 9. All right. These are different bathroom layouts, from the minimum down to not so minimum. Here's that pocket door, depending on what kind of privacy you want. This would be like a washroom, like a secondary bathroom. A lot of houses have 2.5 baths. So down in the living area and visitation area, there'll be a small enclave off. There'll be a sink and a toilet. Okay. So you read through all of this and look at what he says about bathroom layouts. The space and locations of accessories. I think when they laid out this house of mine, they forgot there was going to be a master bedroom and a bath on the end of it. When they got down there, they went, oops, and then they had to back up a little bit. The number of plumbing walls. Now, plumbing walls is what I call a wet wall. A wet wall has all the pipes going through it. So where is your wet wall? Is your wet wall on the exterior wall of the house? If that's the case, then it needs to be extra insulation in there so the pipes don't freeze. If the wet wall is on the inside, then how is the piping getting into the walls? Is it coming in through the attic, or are you going to have penetrations in the slab? And we talked about penetrations in the slab when we talked about slabs on grade. If this is a slab on grade, this bathtub is going to have a knockout in the slab where the P-trap from this goes down and picks up the soil sewer. And most likely it will go over and join the sewer coming off the toilet and then out. Okay? And then this will come down into the slab with a P-trap and then drop down and connect to this. Such as that. All these will have a similar configuration. So there's going to be a hole cut in your slab for that pipe to go to punch up through. And termites like, especially down here, like to burrow up through this and dam up into your wood structure. The best thing to do, there should be, if this is an interior wall, is have a scuttle plate where you can get to and inspect this plumbing in here and come in here and fill that up if you can. But I already drew this pipe as if that's an exterior wall. So who knows? Maybe if this is an interior wall, you could have your inspection scuttle plate here. All right. Again, your mileage is going to vary. Here's an ADA setup for a bathroom. You know it's ADA. They got handrails everywhere. All right. But this is a step over tub. So watching my grandfather getting in and out of the tub was an experience. He had good upper body strength. He just had no legs. And there was no ADA back then. Here we go back to that 32 inches again, minimum doorway. Again, I would use 36, not 32. You do what you want, but your client will thank you if you do 36-inch doors as opposed to 32, especially if they ever get in a wheelchair. Again, y'all need to get in a wheelchair and try it for about half a day and just see what it's like. In different layouts, and this doesn't cover a smattering of the possible layouts for bathrooms. Go grab one of them super duper Yahoo magazines at the grocery store that deal with interior decorating and bathroom design and all this, or just get online and you'll see Rebath. They went out of business, and now I see that they're back in business after their bankruptcy. There are people that specialize in going in and redoing bathrooms. Bathrooms are expensive. Kitchens are expensive. This talks about the ADA guidelines again, and we're not gonna read this. You can read it. This doesn't have any walk-in showers. The big thing now is walk-in tubs where they have a waterproof door, and the door opens and you step in the tub, close the door, lock it, and fill the thing full of water. My mom's got one of those, plus a walk-in shower. This is pretty similar to, except I got a shower here and then the tub's over here when we took out the closet in that second bedroom across the master bedroom and turned that into my wife's Imelda Marcos dressing room. Except we don't have a pocket door. And all those entrances are ADA. Which when I had my knees replaced and I was on a walker, I'm glad we did that. And then when I had my back surgery, I was on a walker for a couple of days anyway. I got back from the hospital, and it was nice to have the extra room to navigate through the bathroom, get into the shower, and do our thing. You just never know. But I'd stay away from that 32 inches. Use 36. Let's see. Oh, what's he telling us here? Range of fixture dimensions. Okay. You get with your plumbing manufacturer, whoever makes the toilet you're going to put in, and look at the various setbacks on the toilets. These are just rules of thumb, and your mileage is going to vary for the water closet, aka toilet. Okay. If it's a bidet or a toilet or whatever. In the lavatory, there are going to be setbacks, and the people that make the toilets, the lavatories, and the tubs will all have a layout setback that they recommend that you use. Same with shower receptacles and shower pans. This just gives you a good idea how much room you're going to need, but this isn't set in stone. You notice he uses all these words: minimum, minimum, minimum. Your mileage is going to vary. All right. If you haven't got the idea that a lot of things are not set in stone, depends on the manufacturer, then you should get there. Water closet width, depth, and height. Okay, here's a range. Is that toilet going to be an ADA compatible toilet? When we replace the toilets, we put ADA compatible toilets in. They're higher. And when I had my knees replaced, and that was a good thing instead of a lower toilet. You don't see too many urinals in residences, but urinals have different heights. If you go into any of the bathrooms, we'll go into the men's bathroom at the Cypress Center, and you'll see that the urinals are set at different heights. There's a bidet. If you don't know what a bidet is, Google it. Now, what kind of bathtub? Is it a two-person bathtub? Is it a get-in Hugh Hefner play bathtub? Is it a giant bathtub, a small bathtub, apartment bathtub? Then you need to get with the bathtub manufacturer and look at what they recommend. They'll recommend the right orientation and where the setback is for the plumbing to stub up. Let's see here. Utility sink. This talks about ADA, showers and bathtubs. Here's your guardrails, double handrails, grab bars, accessibility to get in. Again, lavatory and sink heights. There's no reason to belabor this. Now, water closet stalls, where they're actually stalls like in a commercial building. you'll notice that the handicap or ADA stall is usually on the end of a row. Next time you go in a bathroom, check it out and see how they lay them out, and see where the ADAs are. And then just observe and look and see how they're done. There's an ADA stall at UP on one of the floors that's like this, and then the ADA stalls at the Cypress Center are like this. Everything else is pretty self-evident. Bathroom space, more lighting. Natural lighting by means of exterior glazed openings is always desirable, of course, if you can. However, the more glass you got punched in the wall, the higher your heat load is down here. When we have 3 months of triple digit temperatures. Single overhead light fixture is usually not acceptable, and that's true. LEDs have come a long way. I bought some LED lights for the house. I wanted to put LEDs everywhere, but she who must be obeyed did not like the way they looked. And so we put in other light fixtures. But LEDs have come a long way, and they're dimmable, and they put out a lot of lumens for the amount of wattage that you're buying, and they're not that expensive. So later in this course, we'll be talking about lumens and how much light. And if you really want to know what kind of lighting you need, just go Google it. Go Google recommended lighting in a bathroom, and it'll tell you per square foot. X number of lumens. And there are lighting recommendations for everything, for reading in a library, for studying, for casual reading. And they're set standards. You can find them in the architectural and graphic standards even. But the problem with that, most of that stuff's published and it's a little older. You can get the new recommendation from Google. Let's see. You're going to need more lighting and different kind of lighting, because lighting is not lighting is not lighting. Let's say you got a lady who's really into makeup. Okay. Well, she wants a certain kind of lighting. If you look at professional makeup artists and the kind of lighting that they use when they're doing makeup, that's more of a daylight balanced light. So it can get a good blend. It's not, some nasty little tungsten bulb that casts a yellow hue everywhere. So lighting is a whole big subject. Okay, let's move on. You're going to need to vent. You're going to need to vent the bathroom. You're going to need to vent it. And we're going to talk about venting again. I told you about the kitchen ventilation, right? The recommended in the book was a minimum of 2 air changes per hour. I've told you there are recommendations up to 15 air changes an hour. Now, what do we mean by an air change? We mean the total volume of the room. Okay? The total volume of the room. All right? Now, where in here does he? It's over here. I've got notes someplace. Where is it? Bathrooms require either natural or mechanical ventilation. Well, let me tell you something. If you rely on natural ventilation for a bathroom, you're in an outhouse or a porta-can, okay? A residential bathroom or a commercial bathroom needs mechanical ventilation. And yeah, you can open a window, but what if you got a house that's 6 feet next to you and the wind's blowing in the wrong direction? You're not going to get any ventilation. So here we go back to mechanical ventilation. Provide natural, okay, 1/20th of the floor area or a minimum of 1.5 square feet. A mechanical ventilation system may be employed in lieu of natural ventilation. Well, it better be. You had better provide mechanical ventilation. Ventilating fan should be located close to the shower and high on an exterior wall. It needs to be in the ceiling. If you've got the attic space to do it. If it's a second floor, you can still set it up in there and then 90-degree duck it outside. It should be located centrally in your bathroom, in my opinion, and providing 5 air changes per hour. That's minimum. That's minimum. Okay. 5 air changes an hour is minimum. When we redid our bathroom, I specified the fan. I did the calculations for the volume. You had to go in and you took the whole volume of the bathroom, including the lavatory area. In my bathroom, here's the tub. Here's the exterior wall that used to be the closet. Here's a walk-in shower. Here's a toilet. No, I drew the toilet backwards. Here's the exterior wall. There's a window. Over the toilet, there's a pony wall, which is 4 feet between this wall. And then here is the lavatory. One sink lavatory and cabinet, and there's that nasty pocket door I left in. And then here's the master bedroom. I know some people say master bedroom's colonial. Don't say the word no more. But that's a master freaking bedroom. And here's the door going into it in the hallway. All right. So what I did is I came in here. I took the volume of all of this. The volume. The volume's 3 dimensions, including this. All right. So we have a volume. It's 3-dimensional, right? And it had X cubic feet. Feet to the cube. X feet cubed. Now the minimum recommendation is 5 per hour. 5 of these per hour. Well, I doubled it and I sized the fan for 10. 10 times per hour. 10 of these per hour. So when I went and found the fan, cubic feet per minute, I knew how many cubic feet per minute I needed on the fan. Cubic feet per minute. All right. So it wasn't 10 cubic feet per minute. It's 10 of these per hour. So I needed so many cubic feet. I wanted an air exchange of this volume per hour, right? So then I had this, the fans are sized in cubic feet per minute. So you had to do the conversion of, excuse me, cubic feet per hour. And I sized that fan to do 10 air exchanges, not 5. And it works, and it has worked out very, very well. So I let my fingers do the walking on the internet. Bought the thing from Lowe's and gave it to the contractor, and he installed it. The last thing you want to do is not be able to get that nasty humid air out of that bathroom if you can't open the window. And normally what I do when I run that fan anyway is I'll crack that window. I'll crack this window right here. Now, if it's 115 degrees outside, I don't. But all right, so I think we beat that up enough. Electrical, your modern bathrooms, the code's going to require you to put EFIs in. Good night. Ground fault interrupters, GFIs. Spend the extra money and put enough of these electrical outlets in your bathroom, especially in the lavatory area, for hair dryers, hair blow dryers, electric toothbrushes, et cetera, et cetera. Okay. Plumbing walls need to be thick enough. We talked about framing before and what size piping you can get through them. In a perfect world, your wet walls would be on the inside, not the exterior. Because if you have brick veneer on the outside and you got a plumbing leak, you either got to tear all this out or you got to tear through your brick. And then you got to worry about them freezing, getting the insulation behind them. But we don't live in a perfect world. Let's see. Space is required for accessories such as medicine cabinet. Well, we all know. All right. So what's your storage space going to be in here? Is what he's talking about. Heating. You're going to want to heat the bathroom. In certain areas, we talked to you about up in Colorado, they put radiant heat in the floors. They run hot water pipes in there to maintain a warm floor during the winter. And their floor finishes. It was real popular at one time to have carpet in the bathroom. I've been in some houses where they had carpet at one time. I remember as a kid, and I'm going, why would you put carpet in a bathroom? But humans do crazy things. So your floor finishes. And what kind of floor? If they poured your slab like they poured mine back in 1973, they didn't attend very well to their farm work, and so you got to come in here and spend a lot of money on floor leveling compound to put in good tile. Now the technology and the material technology for tile now, vinyl tile, composite tile that even looks like stone. Got that in my kitchen, got it in the bathroom. Looks like wood back there if I'm not mistaken. Yeah, it's wood in the bathroom. In the hallway. That's all laid down and glued on top of leveling compound. Leveling compound is expensive, but it makes a nice finish. You can have water on it all day long. It's not going to affect it. Not like a wood floor or even a laminated composite wood floor, floating wood floor. All right, I think that's enough. Your air exchange per hour is important for both your kitchen and your bathroom. There's a lot of moisture in here. You need to get that out and be able to dry this out as best you can. If not, you'll run the risk of having mold and mildew. You don't want that. You truly don't. All right, where are we at on time? We're at 1 hour and 9 minutes. That's plenty. That ends Chapter 9. Chapter 10 is in the next weeks ahead. It's finish work. And a lot of it, again, is a repeat. Plaster and lath. Oh, my gosh. Here we go again. And gypsum board. We'll cross that bridge when we get there. Y'all's patience is greatly appreciated. And I'm proud of y'all for sticking with this. We'll see where we go from here. All right. We'll see you on the next video. All right. Bye-bye.